Okay, let's dive into this explainer, and we're going to completely re-grand trigonometry today. I know, you already know the basics, but it is time to uncover its hidden layers. Think of trigonometry not just as some dry classroom chore you had to get through, but literally as the ultimate cheat code for reality. It's this invisible architectural framework holding up the modern world in ways that are honestly way more intricate than we usually realize.
So, to really see what I mean, let me pose a tangible, seemingly impossible physical challenge to you right off the bat. Imagine you're just standing there on the sidewalk, looking way up at this massive, towering skyscraper. How on earth do you measure its exact height without, physically climbing to the very top? It sounds like a total trick question, right? Because unless you've got a helicopter and a massive spool of string to drop down to the street, you're pretty much out of luck. But this exact puzzle is exactly where mathematical framework steps in. As you can see, doing things the hard way, literally scaling a building with a giant tape measure, is not just absurd, it's incredibly dangerous. But the smart way? Well, by using trigonometry, you can stand safely on the ground, calculate a couple of super simple numbers based on your perspective, and boom, you know the height of that building with absolute pinpoint precision. No climbing gear required whatsoever. All right, let's move into section 1, Beyond the Classroom, where we'll look at some real-world applications. We really need to break this myth that these concepts only exist on dusty chalkboards. This math isn't just stuck in academia. It is an active tool solving real-world problems involving angles and distances every single day. From the moment your morning alarm goes off to your evening commute, trigonometry is quietly operating in the background to make your entire modern life function smoothly. Moving right along to section 2, the triangle toolkit, focusing on the core functions. So let's establish exactly what this mathematical cheat code actually is. By definition, trigonometry is a branch of mathematics dealing with the relationship between the angles and the sides of triangles, and its primary purpose? To calculate heights and distances. Now don't worry, we're not going to get bogged down in massive, complex equations today. We just need to understand that this is a specialized toolkit perfectly designed for finding out exactly how far away something is, or how tall it is, just by understanding the triangles that connect us to it. Inside this toolkit, you'll find what we call the big three functions: sine, cosine, and tangent, or, as you'll often see them abbreviated, sin, cos, and tan. These three core functions are the actual mechanisms that unlock these difficult measurements without ever having to make direct physical contact with our target. They're basically the fundamental keys to the whole shebang. Okay, let's zoom out a bit for section 3, building and mapping, where we'll look at physically constructing the world. Let's look at the earthbound mechanics here. In construction, builders and architects completely rely on this math to calculate slopes, dimensions, and structural angles, so, our buildings don't just collapse. Engineers use it constantly to design massive machines and map out those super complex electrical circuits in your home. And surveyors, they rely on these invisible triangles to establish legal property boundaries and map out safe roads. They're literally using these principles to physically construct and organize the very world we walk on. But what's really fascinating here is that this math isn't just for blueprints and hard hats. Whether they're doing it knowingly or entirely instinctively, athletes use these exact same geometric principles on the field every single time they play. When a quarterback calculates the trajectory and force needed for that perfect deep pass, or when a cricketer angles their bat just precisely enough to hit a boundary, they are executing trigonometry in real time. It's basically physics and geometry combined into pure instinct. Now, section 4, moving through the world, covering navigation and travel. Let's see how this builds from local construction to global movement. Just think about how we get from point A to point B. Massive cargo ships crossing these vast, featureless oceans, airplanes navigating safely through crowded skies, and yeah, even the GPS routing cars on your phone. They all use a process called trilateration. This relies entirely on trigonometric triangles to pinpoint your exact location and calculate the absolute shortest, most efficient routes forward. It's literally the math telling all these complex systems exactly where they are in the world. Let's shift our tone a bit for section 5, the invisible and infinite, exploring waves and space. So, stepping away from things we can physically touch, trigonometry actually acts as the language of waves. We're talking sound waves, light waves, radio waves. This math dictates the acoustics of a concert hall so every single person can hear the band clearly. It handles the compression of the digital music we stream, and it manages the intricate communication networks connecting our cell phones. It is literally shaping the invisible environment we're interacting with all day long.
And this really reveals the sheer mind-boggling scale of this toolkit. On a micro level, we use it to map the rapid, tiny vibrations of light and sound physics. But then on a macro level, astronomers use those exact same principles to study deep space, allowing them to calculate the absolutely unfathomable distances between stars and planets. I mean, think about it. It stretches effortlessly from a tiny acoustic echo in a room all the way out to the very edges of the universe. Crazy, right? Okay, so here's a quick little challenge. Here's how you can use this toolkit yourself right now. Stand back at a distance from a building and just measure your distance to the base. Then look up at the top and note the angle of your view. If you take that angle, plug it into the tangent function on your calculator, and multiply it by your distance to the building, boom, you get the exact height. Seriously, try it out. No climbing required, just pure applied geometry working for you. As we wrap up this explainer, I really hope it's clear by now that trigonometry plays a completely vital, totally irreplaceable role in our daily lives. From the bridges we safely drive over, to the music we listen to the literal stars we look up at every night. So I want to leave you with this provocative thought to ponder. What invisible triangles are shaping your world right now? The next time you're looking at the street outside your window, try to see the hidden geometry making it all possible. Keep observing, keep learning, and I'll catch you in the next one.